series, webinar 4th on packet analysis. I'm happy to have you join us for today's session. I'm honored to introduce our distinguished speaker, Mr. Warren Finch from APNIC. Warren has years of experience as senior network analyst and technical trainer, and we are grateful for the opportunity to learn from him. Considering the importance of packet analysis and its broad range of usage from enhancing security, optimizing performance, security monitoring, and forensic investigation, we decided to have our 4th webinar on packet analysis. Over the next 3 hours, we will learn about packet analysis theory and practical lab, exploring its various aspects. So this webinar is not just a platform for passive learning, it's an interactive space where your active participation is encouraged and valued. So throughout the session, you are invited to engage with the content, share your experiences, and possess your questions simply by just using the Zoom chat feature to submit your questions, and they will be addressed during the Q&A session. Furthermore, we are excited to announce that today's webinars will be live streamed on our social media pages as well, and allowing a broader audience to benefit from the valuable insights from shared by Mr. Finch. Once again, thank you for joining us today and your presence and participation enrich our community. Let's make this webinar an engaging and enlightening experience for all. Thank you. And Warren, mic is yours. You can start now your presentation.
Thank you for the introduction. Welcome, everyone. I'm not able to share my video or start my video at the moment, and I'm not able to message to everyone. So I do apologize for that. So welcome for today. There is one question in the Zoom chat in regards to could I focus or prioritize IPv6 packet analysis? The techniques I'll show you today, you can apply the same techniques to IPv4 or IPv6. So there is really no difference of techniques. What I'll be doing is just showing you various ways and other tools for doing that. So welcome. What we're going to be covering today is a quick overview of some of the protocols that are used on a network. Then I will talk about the various tools. I wasn't sure of what level to aim this talk at, so I'm basically going to start with the basics about protocols. And if everyone understands that, then we'll move through a little bit quicker and look at the various tools. The tools that I plan to focus on today are essentially Wireshark, T-Shark, maybe if time permits, TCP dump, and I'll also utilize some online or web-based tool called CloudShark for viewing our packet captures. As part of the tool set, I'll be using some pre-made packet captures already. They're available to everyone. And I'll also show you how you can use the various tools like T-Shark and Wireshark to do the capture as well. Now, it's going to be a different strategy. If you're looking at high-speed networks, you're going to have a hardware device that will do the packet capturing for you. But I'm looking at it from an analysis point of view once the packets have been captured. So let's start with an overview of the different protocols. So there's two various models that are used in training or giving theory about networks, and that is the OSI model and the TCP/IP model. So the idea behind this is that at the various layers of our network, we're going to have our different protocols running. So on the left-hand side, you can see that we've got our OSI model, and we've got our 7 layers here. And I'll talk about each layers and what we should expect to see at the various layers here. And Wireshark is helpful in regards to having the appropriate decryption, or not decryption, but the tools to visualize these different layers that we see in a packet capture. In regards to the popular internet protocols, most of them are using TCP/IP, and so this is the model on the right-hand side that we'll look at. So when we look at the various protocols, we've got layer 2, layer 3, 4, 5, and so on. And at each of those layers are going to be different standards or different ways of communication. And based on those different standards, or what we call protocols, is how you would interpret the packet and the information that is related to those different layers. So what happens is when information is sent across the network, it starts at the application layer using an application. So for example, we've got the web browser at the moment, or Zoom, which is sending the video stream across the network. That video stream is referred to as data. The next part of the layer is going to have a transport information, and it's going to use TCP, Transmission Control Protocol, or UDP. And with the UDP, User Datagram Protocol, that is how they will address it to get across network. And it adds this transport header information. And we'll look at this in more detail a bit later on. But essentially, depending on which protocol is how many packets you would expect to see being sent there. With a TCP, before it can start the communication, it creates a TCP handshake. So that's a three-way handshake, and then it starts sending the data across. With UDP, it's an unreliable protocol, and it basically uses less overheads to send that same information. And it's used for video streaming and other resources. The network layer is where it gets into the addressing of sending information across the network. So this IP header is attached outside of the transport header. And then when it gets passed down to the data link layer, it gets a frame header put onto it, and then it gets converted into the electrical signals that goes across the network as zeros and ones. At the receiving side, it then goes through that same process, but in the reverse order. That reverse order is going to remove the frame header, sending it up the stack to the internet level, where it will interpret whether it's IPv4, IPv6, take that information off, sends it to the transport, and the transport then hands it over to the application where you can see the results from there. So let's start by looking at each of the different layers and how they will look inside Wireshark. If we open up Wireshark, we can see here an example where it's showing the different layers here. So at the top, in the reverse order to what we saw in the previous slide, is the frame information. So it's telling us about how big the information was sent across the frame. And then the next level up is the Ethernet. So it's got things that will have the media access control details. That would be the source addressing and then the destination addressing. Where is it going to? And then the type of protocol that it's going to be using later on. In this case, it's 0x0800, which is the IPv4 standard. And there will be various RFCs that tell you how to interpret this information. If you are using a newer version of Wireshark, you can actually turn on this TCP/IP diagram tool that's available in the newer versions, And depending on which layer you click on, it will show you a diagram of the header information related to that layer. So in this case, it has three components for the Ethernet layer: the destination, the source, and the type. And the type is going to affect what the upper stack interpretation will be for that. So in this case here, we're looking at RFC 826 address resolution protocol, as well as RFC 894, which is the standard for the transmission of IP datagrams over Ethernet networks. And that's going to basically talk about how the datagrams are encapsulated for that transmission over the physical medium or over the Ethernet network in this case. Going up the stack, we then have RFC 791, which is referring to the Internet Protocol version 4. And if we expand that layer of information, we're going to get a lot more details there. So it still has in the diagram the header information for IPv4. So we've got a version, in this case it's version 4, how long the header is. It's got some special services fields about differentiation, and then it's got the total length of the packets. Any extra flags that we're going to need for our transmission, and I'll talk about that a bit later on, but essentially the flags are going to be like the SYN, ACK, and so on, and finish. It has a time to live. The reason for having a time to live is that it's going to basically expire the packet so it doesn't keep sending until it gets to the destination when it can't find the destination. The type of protocol it is using, in this case it's IPv4 is protocol 6, and then we still have a source address and a destination address, which is in the format of IPv4 using the octet of 192.168.1.140, which is a decimal value that we see there. And you can see in the packet itself that we can actually click on the different areas and we can expand out more information from that. Now, everything that I'm talking about, I forgot to mention this previously, is available on the Academy's website. So I'll just flick over to that so you can see it. So we've got this academy.apnic.net. Now, I don't know if I can paste the link into everyone. No, I can't, not at this point. But if you want to get access to it, you go to Academy. I'll just type it out on a notepad so you can see it a little bit better. So if you go to that URL, it's going to bring you to this page, and you'll see here there's a link that will take you directly to the webinar. Once you get to that link, scroll down and you'll see this course materials tab that you can click on. Click on the course materials tab, and then you'll see this blue square with double-headed arrow. Click on that to make it full screen, and then you'll be able to get access to all of the resources we're going to be utilizing today. Can I get a thumbs up if you've been able to get access to those resources? Saw one hand go up, so that's great. So now everyone's got access to that. You can follow along with the slide deck if you can't see it as well. So for IPv4, we essentially are using the RFCs to go through and look at the header information and what we expect to see in those types of packets. For IPv6, it's a very similar process of expanding the layer that we're looking at, in this case here. We're expanding this one here. And you'll notice that the header, the packet diagram, is different with IPv6. So we still have a version similar to what we had for IPv4. We have a traffic class, which is similar to the IPv4 differentiated service. And we have a flow label, payload length, and we have an extra field that is not in IPv4, and that's called the next header. The reason for that is that IPv6 does have a fixed length for its header information, unlike IPv4, where it had a variable size header based on how much data you had. We still have a hop limit, so that's like the TTL. We have our source and destination addresses, just like IPv4, but now we also have an extra field there that allows us to point to another type of header. So we can tell it to expect some extra information using this next header field. I tend to give the example much like a train, where you can have one train engine, but multiple different types of carriages at the back of that engine. And that's what this is doing here. It will then hopefully have a value that tells it that to go look at the next part of the networking stack for that information. In regards to the request for comment, you can look at RFC 8200 for more details about the IPv6 protocol. Going up the stack, we now are at the TCP transmission control protocol settings. And in this case here, we have details about the flags themselves. So if we click here, if you're using TCP rather than UDP, you're going to have that three-way handshake. And we're going to have things like the source port and the destination port. This is going to indicate what sort of application further up the stack at the layer 7 is going to be talking to this packet. If it's a string of packets, sorry, a stream of packets, you're going to have a sequence number. And then if I'm responding, because transmission control protocol is a reliable protocol, so it's going to respond with an acknowledgement that it's received the packet each time, and it's going to use this acknowledged number to do that. It still has a header length and a window size. A window size is sort of like a way of regulating how many packets you can send and receive at any one time. And so what will happen is both parties of the communication don't know how fast to talk. And so what's going to happen is that the sending computer or the sending device is going to just start sending packets as fast as it can. The receiving side will try and process those packets, but if it can't process them in time, it will modify this window size and send a message back to the sender and tell them to reduce or increase that window size, saying send more or send less packets until I can catch up. And that's what that's referring to there. It does have a checksum to validate that the packet that it's received hasn't been tampered with or is usable. If it can't do the checksum, it's not going to send the acknowledgement. And then it's going to have some other information there for other options that we can add in, like the size, timestamps, the window scale, and so on, that we can see here under the TCP options. In regards to the transmission control protocol, RFC 793 is where you'll read more information about that. But you can see here that you've got different types of flags that you get. You've got the urgent, the acknowledgement, the push, the reset, the SYN, and the FINI. So normally with a TCP communication, you're going to have that three-way handshake, ACK, SYNAC, and so on. Looking at the other transport mechanism, we've got the user datagram protocol, and it's a simpler protocol. RFC 768 gives you information about that. But all you need, again, just like TCP, is the source and destination port, a checksum, but it's not going to let the sending party know that it's received it. It basically just accepts it. Notice there's no window size. It's streamlined. And so if the packet is lost in transmission, the sending party will not know, and the receiving party may not realize that it's going to miss information. And so that comes important when you're looking at troubleshooting voice over IP or something like that, where there's latency that causes packets to be lost, or any sort of latency sensitive packets that if a packet is lost in transmission, it causes some issues. So an example of a protocol that uses the user datagram protocol is DNS queries. We can see here the upper stack of the network model is passing that information to our domain name system. Any questions at this point?
I think there is no question so far. So
excellent. So let's continue. And so what we've got, if we look at the different applications that are going to send information across the network. So looking at the layer 7 location, and this is where you're going to start thinking about when you're investigating packet captures hypothesis in regards to what are you investigating or why you may be investigating. And so before we get to that point, I'm just going to show you various types of packets and what they look like in some sort of tool. In this case, it will either be CloudShark or something like that. So let's start with a very old protocol. And the reason why I chose this protocol is because it sends information in clear text. And that is the Telnet protocol. So RFC 854 will show you information about the Telnet protocol, but essentially it goes and sends the information and in clear text. And a lot of people say, oh, but Telnet's a very old application, so why are we focusing on looking at Telnet? Well, it's still being used in a lot of networks, and a lot of Internet of Things are still doing it. And recently, Cisco announced or put out an advisory about the use of Telnet on various different devices. So you can still enable Telnet on routers, and it's sometimes if you've got out-of-band networks and you enable it, you will see the clear text. Also, depending on how old equipment is. I was in New Zealand last week, and there was a device that was still up after 20 years. And so the network operators were going to locate that device and turn it off. And that, I assume, was using Telnet still for authentication mechanisms. So there are different networks and different types of protocols out there. So what I'm going to do is just go and grab a packet capture. And so in this case, if I get you to go to the Academy, and you'll see here, if we scroll down, I've got different types of access here. And so you can see that there's a link to the packet captures, and there's a Telnet packet capture here. In the past, I used to get people to open this up in CloudShark, but I'm just going to download this packet capture. Now that I've got that downloaded, it's going to open up that window. And I've already got Wireshark installed on my system, so I can double click on this, and that's going to now open up Wireshark. And I'm just going to bring that here. And you'll see in regards to this telnet session here, we've got a very simple setup here. So at the top of this packet capture, we've got our information that we expect to see at the various levels. So you'll see which layer is highlighted. By default, it's the transmission control protocol. And the transmission control protocol, if we scroll down on the right-hand side, we can see what is expected in that layer based on the RFC that I've talked about already. If we expand that out, it's not going to show me any application layer at this point, because with TCP, we've got our three-way handshake. And you can see on the right-hand side, up in the top location, in the top pane, there's a column called protocol. And the first three packets are referred to as TCP. The TCP is the three-way handshake that we get, the SYN, the SYNAC, and the ACK. Then the fourth packet is the telnet. So we click on the fourth packet, and down in the bottom left-hand side pane, we get information about those different layers in this transmission. So if we click on the telnet layer, we can get information about that. On the right-hand side, where we've got our diagram for the packet, we can see information that's related to that. Sometimes it doesn't interpret it well. So what I can do is, what I can do in a lot of tools is I can right mouse click on that device, or sorry, that packet, and then I get this option to follow, and I've got TCP stream. And what that's going to do, it's going to go through every packet that is a telnet packet and extract the data from that and piece it back together. So I'm just opens it up in a different window, and I've just got to resize that window so it looks nice and neat. Bring that down to this window here. And what we get here, we get the information of the entire conversation from the receiver as well as the sender. And we can break it down to the packets down here. We've got the client is in red, the server is in blue. So the server is saying, what is the password? The client has typed in capture. Then we see here the server is sending the prompt, which is a dollar symbol. Then the client is sending the character U. And because Telnet has been set up, in this case here, to reflect or to show the characters back to the client, it then sends that same character back. And that's why it looks like it's been double typed. But it's doing uname A and then exiting down here. So that is a very simple example of Telnet. And you'll notice that it's got details about the credentials in clear text. So if you were sending or creating this communication across the public internet, you would be sending the login credentials in clear text through various networks where they could potentially listen in and get those credentials. So it's not a safe protocol anymore to be using. I'm assuming most people have used Wireshark in one format or another. Well, don't worry if you haven't, we'll go through it in a little bit more detail later on. So this is where Telnet was replaced with Secure Shell. secure shell allows you to encrypt the traffic going between the sender and the receiver. And it uses the transmission control protocol port 22. If we look at this, which is a little bit harder to see, sorry about that. So hopefully you've got the PDF from the Academy website. But essentially you have your SSH client. It uses the TCP protocol to create that three-way handshake. From that three-way handshake, so just here, the three-way. Sorry, the three-way handshake is just here. And then it goes and tries to connect using SSH. And so it's going to create a session for the SSH. The SSH server is then going to create a encrypted one-time key exchange. Once it's got that key exchange accepted, it's going to acknowledge that, and then it's going to try and create an encrypted connection to the server for authorization. The server is then going to prompt, and then if I pass that authorization, I now will get an open session and can start sending data, and that data moves through the SSH connection to the server that's receiving the SSH. So it might be a shell of some sort, and then you can just start typing your information in there. So that was a quick introduction to what the protocols are. We looked at a session to do with Telnet, which was in clear text. And then we looked at an alternative secure method of accessing similar information, but using secure shell. What we will see though, even if the data channel is encrypted after the session has come up, we can get some key information about that session from a packet analysis point of view. So if we go back here and we've got the SSH PCAP, I can open that in a new tab, download that. I'll just shut down my Wireshark window and open up this one. Same sort of process as before. We've got our three-way handshake here. Then we start our server client communication, similar to what we saw in the PowerPoint diagram. And on the right-hand side bottom pane, we can scroll down and we should be able to, if I get to, I'm in the wrong packet. If I go here, go SSH protocol, click on the expanded field, I can then click on that, and down here, it will highlight what I'm looking at there. And so all we can see is the SSH protocol. The information that we can get from this, though, is still the source and destination address, the source and destination MAC address, the protocol that's being used, IPv4, and the TCP flags and any information that's related to that. But if we right mouse click on this packet and do the same as what we did with the Telnet session and go to TCP stream, this information is going to be significantly different to what we saw in the Telnet session. I'll just make that a little bit bigger so you can see it. So we can see here the server's prompting, the client is responding, saying, yes, do a Diffie-Hellman key exchange using SHA-1. It then does the supported protocol, supported encryption algorithms, both the server and the client. Once they do that, they then create a key exchange. They then start encrypting the information. And you can see here, it just looks like garbage going on the screen. So there's not really anything that you can interpret from that point of view. And we can see here that we've got the server client key exchange that's happening, saying what sort of encryption it's expecting. So it's going to use the AES 128 CBC. The key exchange method is going to be using that method there. And you've got different key exchanges that you're doing there. If you want to get into detailed analysis of this, you need to have a thorough understanding of the various protocols and the RFCs related to that. And then if you want to look at SSH or the encryption standards and whether you can do things like downgrade attacks or interpret, reverse engineer, you would need to do the appropriate research on that. There is a session that APNIC does on cryptography, so I won't cover it at this point. In regards to the web traffic, it's going to be a similar process. So HTTP is clear text like Telnet. HTTPS is going to have encryption, but you'll be able to see some key information similar to what we saw with SSH. In regards to IPv6, there's a packet here that you could go have a look at. So let's look at the DHCP v6 one. And it's very similar to what we see with IPv4. Just to save time, I'll open it directly up. In this case here, it's using ICMP to query for our neighbor solicitation, neighbor advertisement. So there's a little bit more detail that you need to understand in regards to how the IPv6 protocol works. But we can drill down here and we still get our source addresses. So if I expand this out, we've got our source address and we've got our destination address. And you'll see here that there are some special addresses here, FF02, ::16, FF02, anything starting with that are reserved addresses. And again, we tend to talk about that in more detail when we talk about IPv6. But these are the source and destination address, still has a port and source port, destination port. You can see that here. So in regards to using a workstation to be able to analyze packet captures and to capture various packets, there's different types of tools that you can use. So a more common tool that's been around for quite a long time is called TCP dump, and it's a command line utility that you can utilize to capture as well as analyze. It's very limited on what you can do with it, but the big advantage is in the past, a lot of different Linux-based systems would have it installed by default. So you could use it out of the box without really having to have any specialized software or hardware to do it. Depending on when you studied network engineering, you probably would have come across Wireshark. It's a graphical user interface that you can use to capture packets on a Windows system and a Linux system, and now it's also available for a Mac system. That is a very handy tool. I've opened it up already, and you can see what it's like, and we'll spend some time on it later today doing that. What a lot of people don't realize is that it has a command line interface as well called T-Shark. And most things that you do in Wireshark, you can do in T-Shark. I actually prefer to do a lot of things in T-Shark. The reason for that is that I can then script, or I can get it to look at a whole heap of packet captures in a directory in one go using some bash scripting or some PowerShell scripting. And so that makes it very powerful from that point of view. Whereas when you look at the graphical user interface, you open up one packet capture at a time, and it's a very manual process. There are scripting capabilities, Lua scripts that you can create to help speed up that process or to interpret the different types of packets you've got, or customize the Wireshark interface to interpret the packet if it's a custom packet or custom protocol. CloudShark is great for analyzing packet captures or sharing the packet captures in a web interface with other users or for training purposes. It used to be a free tool. Now it's gone commercial, so it's not as easy. So all of those packet captures that I've downloaded from Packet Life used to be linked to a CloudShark account, but that's no longer the case anymore. A tool for network traffic analysis is Zeek. And what it does is you replay a packet capture and it goes and looks at that packet capture and tries to categorize the different packets that are inside that packet capture. And it will give you a summary of that. So it'll give you a summary of web traffic, DNS traffic, and any sort of traffic that it thinks is weird. And that will make it a lot quicker. So if you're new to incident response or detection, you might want to look at the Zeek tool. And we do have training on that as well. Now, if you come from a Windows background, you're probably going to use Wireshark. But Microsoft, since Windows 10, created a tool called pktmon.exe, which is a command line interface packet capture tool built into the Windows 10 and above. If you want to use it, it is very limited, but it's there if you want to do it. You may find that you don't have permissions to install Wireshark and do packet captures, but you may have permissions to do the pktmon.exe. The other thing to be aware of is if you're running a Windows environment and someone compromises your system, they may use this tool to investigate lateral movement or what other packets are on the network. So just be aware of that as well. So looking at each of the tools in a little bit more detail, let's start with the TCP dump. It's a command line utility and it has quite a lot of features available there. You can get help from the manual page, or you can just do TCP dump -- help, like we can see here in the screenshot down here. Looking at that, if we want to use it to do a simple packet capture, we're going to use the command TCP dump. -N means don't translate the numbers into names, so don't use name resolution. -I is the interface to listen on and the name of the interface that you want to use, so EN0. And what sort of traffic, so I can limit it to just DNS traffic. So using the port 53 to be able to limit that from that point of view. So what that will do is it'll give me a nice little output that looks like this, and we can start seeing a timestamp on one side, the type of protocol that it is. So in this case, it's IP, the source IP, the source port, the destination IP, the destination port, and then the clear text information that's related to that. And we can see here that we've got a system using a large port number, 59,524. So that indicates it's most likely the client, because a port over 1024 is usually meaning that it's not a reserved application. Port 53 is usually reserved for domain name service, and so that's why we see it being hit on port 53, as well as why we set this as our capture filter in this case. We've also haven't restricted it to a particular IP protocol. So we're capturing both IPv4 and we're sending IPv6 details about DNS traffic as well. And so later on, we could potentially be capturing the IPv6 traffic as well. Now that's just going to stream the output to your screen until you go Control-C to stop that. If you want to save it for further analysis or for sharing with other people, you can use the -W to write the information to a file. So the first part of the TCP dump command is exactly the same as what we saw previously. We don't have a capture filter for port 53, but we're saying send all the traffic to this file called test_capture.pcat, and the -C is for a packet count of 100. So only capture 100 packets to that file. Now that we've got the packet capture file, what we can do is replay that, and we can use a display filter to say only replay anything that has information about port 443. And that 443 is usually used for HTTPS. Anything that is outside of that, like port 21, port 23, it will still be in that file, in the packet capture file, but it won't be displayed to the output. So this is a way of zeroing in on particular packets inside that packet capture. And you do this as a way of troubleshooting. I tend to like to capture all traffic in one go rather than doing a capture filter where I restrict it to a particular type of traffic, because there might be other information that you're missing out on. And we'll look at this later on. Other examples that we can do. So we're still doing the no name resolution, very similar, but what we've done is we've joined the -N and the -I together as one flag. And what we're saying is any traffic as a capture filter that is destined to that IP address. Doesn't matter whether it's the source or the destination, you're going to go and capture that packet if it's got this IP address in it. If we're looking at it from a particular machine, so you think that this machine might be infected or it's trying to do lateral movement because it's been compromised, you can specify the source of the IP address. And the other thing is that you might be trying to figure out how many people are trying to access a certain application server. So you would use the destination IP address and be able to do the capture that way. Now, I'm using IPv4 here. IPv6 is going to be very similar for that. And you just replace the IPv4 address with the IPv6 address. If I want to capture anything to do with a particular protocol, I could specify the protocol after the TCP dump. In this case, it's transmission control protocol. I could do things like FTP, HTTP, and so on. And we'll see examples of that on the next slide. So if I really want to drill down and I understand the header information and particular what the item number is, and so this is where you need to go and have a look at the RFC, I'm going to drill down, in this case here, at the TCP protocol, and I want to look at, in particular, option 13. Option 13 is related to the flag, and the flag setting is going to have a value, and that value, number 2, is equal to the SYN flag. If I'm looking for ICMP v6 packets and I'm looking for neighbor solicitations, again, I'm looking at particular options. So I want to drill down on a protocol called ICMP, version 6 in this case, as well as, so not or, so it's got to be both, IPv6 header, and I'm looking at the value field or value option number 40, and the value I want to use is 135. So neighbor solicitation is this value here. 136 is the neighbor advertisement, and the actual field that we're looking at is that one there. again, this information is pulled out of the RFC. So being able to go and look at those technical documents to understand the layer in the OSI model or the TCP/IP model will help you. Wireshark does make it easy for you. So if we went back to our IPv6 protocol, let's grab that one. And if I bring that down here, so we've got a neighbor solicitation protocol I've selected up in the top field up the top here. So let's expand this out here. And what we can see here is our internet protocol here. So let's go to our internet protocol and we can see our flags. Let's here, right here. So we can see here the type, the neighbor solicitation is 135. So that's the value where I get that 135 from. The field value is a little bit harder to get. So I can go to the filter field reference, and that's going to open it up in our, I'll show you this later on actually. That's not going to help because that will just opened up a web page with the documentation related to the different fields there. But what I can do, yeah, it doesn't look like I've got the information here. But essentially, I know from the RFC that that is field number 40 in this. In regards to the UDP packets, we've already seen the DNS, but basically it has similar field types. So there we get our timestamp, our source IP, source port number, destination IP, destination port, the query ID. Now this is where if we wanted to do DNS cache poisoning or investigation about that, you would look for this query ID and see if it's been replayed or there's been some sort of sequencing. But this is what an attacker would do on your network is they would look for DNS query packets, grab this sequence or query ID, and then try and respond quick enough with a fake DNS result and send that back to the client. And hopefully the client accepts that as the true query and add that to their cache. And from that point on, they have the false information. And that's what DNS poisoning is, or DNS cache poisoning in a nutshell. From a TCP packets point of view, we get very similar information. Only thing is that you'll notice that the flags are compressed. You don't get to see the whole flags in one detail unless you go into a little bit more investigation. And you can see that this one's a push flag. We've got the sequence again for our acknowledgements that we get there. The window size is important, and the length, depending on the type of packet, you may want to investigate how long that is and if packets are being dropped and so on. So they're the different types of flags that you can get. Send, reset. Wireshark is a graphical user interface tool that you can use for that protocol analysis. And I've already alluded to most of this already, but why would you use it? And it's not an intrusion detection system. It will only read the packets. You can't use it to manipulate the packets. So you can capture, you can read, but you can't manipulate those. So there are other tools out there where you may want to be able to do that. And things to be aware of is that if you're going to share your packet captures, you may need to sanitize that packet capture first by replacing or removing certain information or certain packets. So replacing, say, the IP addressing that you have in there. because it might be an out-of-band network. You don't want people to know about those IP addresses. To install Wireshark, it's straightforward, and we'll do this in the lab a little bit later on, but there are various ways of doing it for Windows as well as OS X. Once it's opened, you're going to be able to get access to this, what's called the default page dialog box. And so what you'll have is a welcome to Wireshark page that you can see here. It's going to then have a listing of various interfaces that you have permissions to view. If I wanted to add a display filter, say that port 53, if I want to add a capture filter, I would add that there, which means it will only capture those types of packets. And then I click on the interface that I want to capture the packets on. And you'll notice that if there's traffic on that interface, it looks like a heartbeat. And we can see that down here. Once I've selected the interface, I've added a capture filter or not added a capture filter. I can start the capture by clicking in the toolbar or pressing enter, and it will go and show the packets to screen. I can stop it by clicking on the red square in the toolbar, and then I can also restart it. When I go to restart it, it will say, do you want to save the existing packet capture or not? And that's where you can then save it out. Once I've got a capture, I can use this field here to display only certain protocols here. So for example, the packet capture that I've got open, I've closed it now. I was going to say for the ICMP v6, I could just type in that as my display filter, and it'll only show me those packets related to that. If you are wanting to capture packets, the software needs to have full access to your network card to be able to then listen to all packets, whether it's addressed to your system or not. So you need to enable promiscuous mode, and it's usually advised not to do that on a normal machine. So the reason for that is then they can start listening for other people's packets. If you're looking at wanting to capture Wi-Fi, you may need to have a special hardware device that is supported by the packet capture tool to be able to interpret the Wi-Fi signals. And there are various help or online references that will help you with that. As I said, when you start the packet capture, it will open up this dashboard that looks like this. Up the top is our main toolbar. We then have our packet list pane, and depending on the view that you have set up, you're going to have a side-by-side view for the bottom half, like what I had, or you might have a top-down view like what we've got here, where we've got 3 different views. We've got our different layers in the middle here, and then we've got our actual bytes, the packet bytes pane. And this is where you see the hex value and the ASCII equivalent down there. I tend to not use this pane as much. I tend to use the diagram pane instead. I tend to only use this if I'm looking at further analysis and I'm wanting to grab certain bytes of information and then take those out for further analysis at a different time. As I've already said, the capture filter will only capture traffic based on that. So in this example here, we're saying capture any traffic that's not encrypted using port 443 and is not address resolution protocol. So it's only going to capture protocols that aren't using HTTPS and ARP. And so we can see here we've got DNS protocol, we've got HTTP protocol, we've got ICMP, as well as TCP. But we don't see any HTTPS, we don't see any address resolution protocol. Okay. So that means that we won't see the full picture. The display filter is going to take that whole packet capture and filter it down to just that information. So we've got our capture filter happening still. So port not 443 and not ARP. But now I'm saying only show me the DNS packets that are in this packet capture. And we can see here DNS, and we've got the different types of queries that we see from that. Now, depending on the way that you write your filter, you can right mouse click in Wireshark and you can say apply as filter. So if you're new to writing filters, that is one way of learning about how to, the format of that. You can go and have a look at the online documentation. There are lots of protocols that are supported inside Wireshark, as well as various different fields. So it's too much to do in this short amount of time that I'm talking about. So for further reference, go have a look at that there. To start you off, I've got a few examples of filters that you can apply. Now, depending on the version of Wireshark that you have, there has been a little bit of changes between the way that the filters will be applied, as well as the tool set. So T-Shark filters, the TCP dump filters, and the Wireshark filters are all very similar, but they may not work as I show you here. So you may need to still apply some look at it and figure out what is the format that is needed for the version of Wireshark that you're using. So if we just want to filter out IP addresses, so we want to grab any information or any packets with that 10.0.0.0.1 IP address, we can do IP address equals equals. If we want to look at a conversation between two IP addresses, you can just add the double ampersand to say, I want to include only packets that has these two in it. If I want to look at a particular protocol, I can do HTTP or DNS. If I want to look at a custom TCP port, I can do port equals equals 4000. And this is handy for if you're investigating command and control or beaconing traffic. You might find that you've got an indicator of compromise, an IOC, where it says you'll see outbound traffic on this port number. And so you would do a filter on that to see if you see that. If you're seeing servers or applications constantly dropping connections, you might want to do a search for the TCP flag reset equals 1. We can pull out the actual web URLs, the HTTP GET requests, using that information there. It's a little bit more complicated than that, but I've got to go in and break it down a little bit more, and we'll do that in the lab. From a contains point of view, and so instead of getting an exact match, you can say, go look for the TCP data packets and see if you can see anything with the string rviews in there. And if you are able to return that to my screen. And if you want to not see certain protocols, you can use the exclamation mark as a negative in regards to do not show this. So if I've got one or more protocols, I can do exclamation mark, open brackets, ARP or ICMP or DNS, close brackets. And that means don't show me that. I'm not interested in that type of traffic. I'm interested in the other type of traffic. As I've already said, we can go through and right mouse click on certain protocols that are clear text and go follow the TCP stream. And that's going to be important later on when we start our lab environment. When we follow those protocols streams or the TCP streams, we get the clear text version of that. Now, depending on your packet capture, you're not just going to get a couple of protocols like we have in this example here where we've got TCP and Telnet. You might have a whole gambit of protocols in that one packet capture. depending on how long you let it run for. And so what you can do in the Wireshark, you can go to the statistics and you can get a hierarchy of all the protocols and where they fit in that packet capture. So we can see here we've got an IPv6 packet capture, and it's showing me here the type of traffic. And in this case, it's a little bit suspicious. We've got BitTorrent, but we can see how many packets. 0.1 of it is set as IPv6. Most of it is IPv4. It's got a lot of data because it's got 82.9% of them data. It's using TCP. And then we can see there's 3 of that using some sort of BitTorrent to do that. So that's a great way of getting a quick summary of a packet capture if you don't know what the contents of it is. In regards to the conversations, we can use the menu statistics again and go to conversations, and then we can look at Ethernet, IPv4, IPv6, TCP or UDP type conversations. And depending on which one you've clicked on, you'll be able to see the source address, source port, destination address, destination port for that conversation. So we can see here that there's quite a lot of web traffic. Port 443 is doing that. And so we may not be able to interpret much from that. If it's encrypted traffic, you're going to have to be able to decrypt that using what's called a certificate or a shared key. And so you can actually set it up so that when Wireshark is going to replay or open up a packet capture, it uses that shared key or that secret file. And you do that by going into the edit, going down to preferences. It will pop up this window in the background for preferences, and you will scroll down until you see TLS, and then you go browse, find the text file that you've got. And the way that you enable the decryption keys, if we get time, I'll show you that, but it's in our lab guide. There's also a tool called T-Shark, and everything that we just looked at in Wireshark, we can do exactly the same in T-Shark, and that'll be our first part of the lab later today. I've already mentioned about Zeek and how what it does, it looks at the packet capture file and it outputs log files based on those packet captures. So it tells me connection information, protocol specific information, whether there's something strange or observations about that. So it's got things like a weird log or known certificates, but protocols, it will categorize it out as HTTP, web traffic, file transfer, DNS, and so on. So it's a very powerful tool to get a quick analysis of that. So what we're going to do is we're going to stop the slides at this point here, and we're going to transfer over to getting you access to the environment. Did you want to say something?
Thank you, Warren. Just wanted to ask something before we go to the practical session regarding the tools which are used in switches, such as EPC or switch port analyzer in Cisco devices, for example. What are the difference between Wireshark, for example, and such tools which run in switches, except that they are in different environments?
So in regards to the tools that you run on a switch, they usually So are you looking at the span port option, or are you doing a direct saving to a file? Because remember, a lot of the switches that you have, you're going to set up a span port, you're going to then mirror the traffic to somewhere else where you then capture those files. Yes, some of the devices will capture directly, but then you then need to analyze those. So this is where Wireshark comes in to analyze those files. You can also use Wireshark to capture the information as well. And I've also noticed there is a question in regards to suggest me a tool for packet analyzers for long time periods. So the way that you would do long time periods, the way I tend to do it is I use something like Wireshark, but I have it on a file rotation system. So depending on the time snapshot that I need, so if I need 1.5 hours as my window to do analysis on, I will create 3 files that capture about 30 minutes of traffic at a time. But again, it depends on how much network traffic you have. So this is a figure that you would need to come up with yourself by basically creating a packet capture for 5 minutes and then calculating out based on that size of the file after 5 minutes, how much you need to cater for the 30-minute period. The other option is that you can, in Wireshark, you can set it to a default file size. So it will always be, say, 500 meg in size. So I create 3 files that are 500 meg in size. And then what I will do is I will rotate those out. So when one of them gets full, it moves on to the next one. When that gets full, it moves on to the next one. And then when that gets full, it goes back to the beginning one. I haven't actually put that into the lab guide, but I can share that with you at a later time. I'll put it into a link on the Academy page if you like, because it's been a while since I've had to set that up. But when I worked for a managed service provider and I was troubleshooting latency issues, that's how I would do long-term file captures.
Thank you.
In regards to the switches, I tend to just use the span port, a mirrored port, to be able to send it somewhere to capture. The reason for that is that usually the switches and the hardware, the routers, you don't want to do the file capture on those because they're busy doing the data, the traffic, moving the traffic through your network. Does that answer everyone's questions?
Yeah, thank you, Warren. There is one question though in the question Q&A. It's about tools for packet analyzer for long time periods.
Yeah, so that's what I just answered. Like I would use Wireshark or T-Shark, and I would do a log, a rotation of the files. So I'd create, say, 3 files that were 500 meg in size, and then I'd get it to rotate. I'd need to, as I said, I haven't done it for a while. I'll need to go back to my backups and show you and write a little lab guide on how to do that, because it's been a while since I've had to do it. Does that answer everyone's questions?
Thank you, Warren. I think we can go ahead with the lab session.
Okay. So for those people who want to do the lab, can I get you to go to the wiki page? The event page. And on the event page, we've got this T-Shark Lab PDF. I tend to get people to start off with the command line interface and learning about the display filters and the filters that are there and being able to interpret some packet captures first, because then it makes it a little bit easy. for you. So what we're going to do is we're going to connect to, you can do this on your own system if you'd like. I have written the lab guide based on a Linux installation. And so it will be a little bit different if you're using Windows and T-Shark on Windows. So I've created a container for up to 30 people if you are interested to do that. So we're going to basically SSH to our system. Once we SSH to the system, we're going to install the required software for Wireshark. So we're going to install our software properties common, add the Wireshark repo to be able to download the software. Then we're going to update and install Wireshark. Once that's installed, it's going to ask you some questions about, are you going to allow anyone to do the packet capture? And we will say yes to that. We're going to add the current user to the Wireshark group, so that way we don't have to keep running it as sudo. Then we log off the system and log back on. And once we're logged back on again, we are able to run Wireshark from the command line. Now, Wireshark is a prerequisite to get T-Shark working. The reason for that is all the tools that you need for capturing and so on are built into the Wireshark. And so we're going to install T-Shark, and once we've got T-Shark installed, we can download some files and start doing the analysis. So what I would like people to do is, I've got a attendees list there. I'm going to give you a group number from the 1 to 4. So I'm not sure if I can see everyone there, but I'll try and say everyone's names. So Abdul, you're going to be group 01. Ahmad Walid Saeed, you're going to be group 2. Azmullah, you're going to be group 3. Faradullah, you're going to be group 4. Hassan, you're going to be group 5. Rabin, you're going to be group 6. Sujit, you're going to be group 7. And Sahir, you're going to be group 8. If anyone on the panelists would like to do or have a container, just let me know and I can allocate a group number to you. Now, to log into the system, I'll just show you the settings here. So what we're going to do is we're going to use, now for those people who were late and not sure where we're at, the Academy is where the events or the resources are. So academy.apnic.net. Click on the Academy. So I'll just throw that in there. Scroll down here, you've got the packet analysis event of the homepage, course materials, and then you click on this blue square, and then you'll be able to get access to these resources here. To SSH to the event, we're going to use the SSH APNIC at 202.125.97.43 is the jump host. And if you're running Windows 10 and above, you'll be able to just open up a command prompt and type this directly in. You don't need any special tools. Or if you're familiar with SSHing with other tools, you're welcome to use that. I'm just going to open up my Windows subsystem for Linux and demonstrate this. So if I SSH, it's going to ask for a password. That password is training or lowercase. And when you get into here, you'll see a menu asking what group number you were given. I'm going to take group 30 to be at the end of the list. And so I just type in 30 and it's going to ask me for the password again. So I type in training, all lowercase, and that's now changed my prompt, and you will see I am on group 30 at this point. Now, it's important that we don't share the same resources, because that will cause issues later on when people are trying to do the installation of software. So just be aware of that. Try not to utilize someone else's system. If I type in exit, it's going to take me back to that menu. If I want to get out of that menu, I can type in 31 to quit, and it takes me back to my own system. So to demonstrate that again, SSH to the jump host, so it's SSH APNIC at 202.125.97.43. Password is training, or lowercase, and then you type in your group number to SSH to that system. The password is training, or lowercase. Now that I'm in, I'm going to do the sudo apt update. Password is training. And what this is doing is just going out and checking for any software and the updated list of software that can be installed. And then I'm going to tell the system to install the dependencies that are needed for Wireshark to work. And that is the software properties common. And that's going to go out, download that, and extract it. And then I tell it to add a location where I can download the Wireshark software. So you can see here at the top of the list, the get one, that it's now queried Wireshark-dev stable for anything to do with the Ubuntu system. Now that I've done that, I can do the update again to say, go get the latest version of that list. And then I can say, I want you to go and install Wireshark. Now, we don't have a graphical user interface for this system. So this is why we're going to use T-Shark to do the analysis. So can I get a thumbs up or hands up if you've been able to get access to the system? If you're stuck, just let me know and I'll help you. Zaire, thank you for putting your hand up. I'm assuming you're all good and you've been able to access. So it looks like I lost someone. Ruben has dropped off. As part of the installation, it's going to ask, should non-super users be able to capture packets? In a production system, you shouldn't really be installing this on, but we're going to say yes. So that way you don't have to run it as a super user, which is probably a safer bet. And so I just use the tab key to change between where the red is on the no to the red on the yes, and then I press the space bar. And that goes ahead with finishing the installation. Now that has been installed, I can go ahead and install T-Shark. Actually, I might add my user to the group first, and then I'll log off, log back in, and make sure Wireshark is working first. Sudo user mod, so modify my user. -A means add to group with the capital G, which is the group called Wireshark. And then I want to add the current user, which in this case is APNIC. And I press enter. I log out by doing exit, and then 30 to log back in again, password training, and I should be able to now run Wireshark without having to be super user. And I'm just going to install T-Shark with this command here, sudo apt install -y T-Shark. Password is training. T-Shark -- version shows me the version of T-Shark that is running, very similar to Wireshark. Once everyone's gotten to that point there, can I get you to do a thumbs up or type in yes into the chat so I can see how everyone's going before I move ahead? Any questions? Now that we've got T-Shark installed, we should be able to download a sample zip file from the internet, which is this location here. We extract that zip file, and then we'll be ready to start using T-Shark to answer some questions. So there's a question in the Q&A section asking about sharing the URL of the PDF. So I've just pasted the answer in there. So if people aren't sure where to get the PDF from, you will be able to grab it from the Q&A section. I don't have permission to send it to everyone in chat. I can just send it to the hosts and panelists. So if someone who is a host or a panelist that has permission to send to everyone, thank you. So for the person who asked about doing the long time periods, I've put a link in there that shows how you can do the capture using Wireshark, using what's called a ring buffer. And that's what I was referring to about setting how big your file's going to be, how many files you want, and then it just goes through there. Looks like we've got an extra person here. So someone's logged in 3 times. So if you've logged in 3 times, you're welcome to let me know if you need another group number. But groups 1 through to 8 are in use. So we might continue. So what I'm going to do is I'm going to create a directory to store these files in. As you can see on the screen here, I've got the make directory -p. I'm going to call it pcaps, change into that directory, and then I'm going to use this command to go to this web URL and download this zip file. Then I'm going to extract that by installing the unzip command or the unzip binary, and then I unzip it. To save time, I'm going to copy that. And what you should see is that you've got this file here. I'm going to install the tool unzip. And then I'm just going to use the unzip-j exercise. And unfortunately, luckily, yeah, it was created on a Macintosh, and that's why you've got these ._ files there and the dir store. But we can see we now have telnet pcap, FTP, chat, covert info, foobar, zip, and so on. So what we're going to do is use T-Shark to go and look at this file. We'll start with just the Telnet one to start off with, because that's in clear text, and it makes it a little bit easier to see what's happening with that protocol. And most people are familiar with what Telnet is. So what I'm going to use is the T-Shark command, -R, to replay a packet capture file. And in this case here, I want telnet.pcap. And if I only want to look at the first 10 records or packets inside this packet capture file, I can use the head command. And we can see here the packet number on the right-hand side. So we've got the, on the left-hand side, 1 through to 10. We've got a timestamp in the next column. We've got our source IP address, destination IP, the protocol, the size, the port number from the source to the destination, and then information about the payload. So we can see here that this top packet is a SYN, the second packet is a SYN-ACK, and the third packet is an ACK. So that's our TCP three-way handshake that's occurring. Then we've got our Telnet data, and it's not showing us much details about that. And then we've got our keep alive packets that are happening with TCP. To get an idea of how many in the packet capture, how many packets there are, I'm just using the T-Shark to display the output screen, and then I'm using tools that are built into Linux to extract that information. So head is a Linux command, WC is a Linux command for word count, and -L means just count the lines. So there's actually 92 lines of information in this packet capture, or 92 packets. We can see the IP address of 192.168.0.1 and another IP address of 192.168.0.2. So if we want, we can just say, let's grab, and we can see here on the first packet that the destination IP of 192.168.0.1 is port 23. So that's the Telnet server. So if we want to see any information that is destined for that IP address, we can use the arrow up key, and we can say, show me the IP destination that is equivalent to this address that we want up here, which is the 192.168.0.1. And if I just want to grab the first 10 packets of that, I can see here I've got packets 1, 3, 4, 6, 7, 10, 13, 16, 17, 18. So it's skipping every so many packets because of the source being the destination being the server. You'll also notice that we're still getting two lots of different protocols. So we're getting the Telnet one, we're getting the TCP protocol. If we want to, we can tell it to just focus on the Telnet protocol. So it's going to say, grab any Telnet packets that have the IP destination of the Telnet server. And so we end up with these packets here. Now, in Wireshark, I did a right mouse click on a Telnet packet and said, follow TCP stream. We can't really do that here. There's no right mouse click in the command line, but what we can do is that we can drill down and have a look at particular information. So we can have a look at whether there's other packets inside this. Remember I mentioned about the different statistics menu options. So there was the conversations So I can use that to my advantage. So I can go back to, so I'm just arrowing up, T#-R, telnet -Q means quiet, don't give me as much information. And -Z is particular fields that I'm focusing on. And in this case, I'll look at TCP conversations. And we can see here, it now gives me an example of the TCP conversations between the client 192.168.0.2 and the server, which is on port 23 over here. How many frames were sent, how many bytes, and so on in the directions. I can also check this using a more advanced filter and saying, let's go and have a look at, we've got this conversation of 192.168.0.2 and .1. So what I can do is I can say, let's look at those particular fields. So in this case, I use the -T and I specify the type as being fields. And in particular, the extra information I want to use is IP.source. And the other field I want is IP.destination. And what this is going to do, it's going to grab just those and display that. So it no longer does the timestamp, the packet count, and so on. It just grabs out those two fields that I'm interested in. But you'll notice those two fields actually are repeating. So I've got the 2 repeated 3 times at the top of this list. Then I've got the 1 and so on. So I can use tools inside Linux to say, let's just get a summary of the IP addresses in this packet capture. So I need to sort it so that way it's in numerical or alphabetical order. So I use the sort command. And then what I'm going to tell it is to do a unique, so only show me the unique versions of that. So see how we've got multiple duplicates lines with exactly the same information in this space here. I can say, once it's sorted, squeeze them together and count how many of those you put in as a summary. And so now I can do a -C and I can see the conversation coming from the server, there's 44. Coming from the client, there's 48 packets. Now, if there was more than 2 IP addresses, I would have a stream of IP addresses. And I can use this then to get say the top 10 talkers or the top 10 destinations. And I've got a PDF document where I use TCP dump to demonstrate that. And if we get time, we can start that lab as well. How's everyone going? Any questions? If there's no questions, what we can do is using that more advanced feature set here, I've used the special fields for the TCP conversations. I can also tell it to follow that TCP stream and to show me the ASCII value based on our first packet. So using the T# command, I can say follow, in this case, TCP, ASCII, and the first packet, so or the first stream of information, which is, because it's programming, it starts with the number 0. And so what it's now done is if I scroll back up, you can see here there's a whole heap of information that's coming from this. So it's got the follow TCP stream, this TCP stream equals 0, node, which is the client, talking to the telnet server, and then it's got some information about the connection, how it's going to display the information, the operating system, and then it's got a prompt that you can see here for the login. Then something's typed in as fake, password is user, and then we've got this message of the day banner that gets displayed and some commands that are being displayed there. Just jumping back. So normally what I do is I spend a bit of time talking about packet capture analysis, and then we start the exercise, but I thought with the time constraints that we've got, we'll start the exercise. So this is what we're looking at in regards to this telnet packet capture. We need to reconstruct the telnet session, and we want to figure out who logged into the 192.168.0.1, which is the telnet server. And then we want to figure out what did they do once they had logged into that server. So that's where we're at the moment. So we've got that full display of information, and this is what the Wireshark, if I right mouse clicked on it and follow TCP stream, would output, and you could manually answer those questions. But I want to show you how you can make it a little bit easier and be able to drill down into the packet in more detail. So what I've got here is the same command, but I'm now going to use some of the inbuilt Linux tools, in this case, a search command called grep. And I'm going to say, I want you to find information to do with our login and password. So I could just do a grep, and if I use a -E, that means I can use a regular expression. So I want to look for the keyword login, and I may want to look for the keyword pass. If I press enter, I now have information that looks like that. So I don't really get much at this point. If I scroll back up, this is one of the issues, is that you need to understand what format you're after. So if I scroll back up, I can see here that I've got the word last login here, and I've got login at the start of the line, and I've got password in a capital P. However, I did a lowercase p, so it may not show that. So if I go back up here and change that to a uppercase P, I now get login and password, but I also get other equivalent logins. So if I want to improve that, what I can do is I can say, only look for the word login at the start of the line. And if I do that, I now have drilled down into those two key areas of that output. But that doesn't give me the actual login and password information that was typed. So if we go up and have a look, we can see here that the login is then typed on the second line after that field, that login has been prompted. So what we can do is tell the grep that if you find these strings, show me the 2 lines after. So with the -A and press enter, I now get login, the number 6, fake, password, the number 6, user. So if I was doing this as a ticket to investigate, as a managed service provider or an ISP investigating something, I could add these notes using the tshark command directly into my ticket. So it makes it easier to replicate. Any questions about that?
I think you're all good. There are no questions so far.
Everything that I'm covering, so this is where I did the conversation. And this is where I followed the TCP stream and showed only the password and login details. If I scroll down, I can do a lot more with this. So I can now answer the second part of the question, which was after logging in, what did the users do? So using that same sort of concept where I'm using the search for a field, I can go and look at the output that came to the screen. So let's get rid of the grep command, and I'm just going to do a less. What we can see is the information that's coming through, so the login, the message of the day banner, and we can see here that we've got a dollar symbol as a prompt, and then we've got what looks like a command. And then the responses to that command. Then we've got another dollar symbol, and then the ls command, which is a Linux list directory command, another dollar symbol, ls-a, which is another Linux command, and we can see some information there. So based on that, we can use that same grep command that we had here to look for the dollar symbol, and we don't need a regular expression. Only problem is we also get some blank lines. So what we can say is -F to ignore white space, and it brings back everything that isn't a white space, and it shows us the commands that are there. Now, what I can also do is I can specify that I want that to be at the start of the line. So I think that's what I want, is those commands. And this is where I just build up my queries each time. And I need to do it as a regular expression, so -P. I need to escape that. I can't use -E. That's why it's not going to work. The dollar symbol is seen as the end of the line, and so it probably won't allow me to do it. So yeah, I'll just leave it without that. So using grep, there are some restrictions. I can only get it to that point there. But if I wanted to, I can use a more advanced version using awk to go and do a complex version of that. Now, normally, if you're not familiar with Linux commands, I've got another talk that I tend to do that will use awk, and it just basically goes and grabs those commands for you. So it's saying, in this case here, look for the start of the line where there's a dollar symbol, and then just grab the second line after the dollar symbol and save it into the array. And then it'll keep doing this until it gets to the end, and then it prints it out. And so it's showing me just the commands in this case. So again, this is a way of just drilling into particular information. So I've now answered those two questions. So we know who logged in. So the username was fake, the password was user. And what they did after they logged in is they basically pinged Yahoo, did a directory listing, and then exited. The next exercise is we're looking at a packet capture of a ping packet, so ICMP. And we want to figure out whether there's something strange about this packet. So let's go back to our ping packet. Sorry, so T-Shark-R, covert, and I'm just going to run it. And it's not a very big packet capture. There's actually only 2 packets in there. So there's not really much in there apart from a echo ping request and an echo ping reply, as we can see here. But we really can't see anything of detail. And this is where, if we had a graphical user interface, we could maybe look at the extended fields. But this is where the T-Shark reports come in. And there's particular reports that we can focus on. In particular, the different field types that are available to us to drill down on. So if we do a look at this field, we can see that there's a lot of pages and pages of information about various fields that we can use to filter on or to drill into for more information. We're interested in fields that are to do with ICMP. So I'm going to use the grep command. -I means case insensitive. And I want to see how many of those fields there are. We can see that there's still quite a lot of ICMP information there as well. I can see that there. If we look at this packet capture, so I'm just going to replay it again. What we do notice is here, where the 182 is the size of the packet capture. Now, essentially, a ping packet is basically a packet that sends some sort of buffer, a very padded datagram across the network, and it's usually the alphabet, and it's not going to be that big. It should be less than, say, 76 bytes, whereas this is more than double the size of a normal ping packet. So from my point of view, that is a bit suspicious. And this is where you get experience. The more you look at packet captures, you start looking at what is a normal packet and understanding what that is. So what we can do is in T-Shark, we can actually tell it to look at the length of a data packet and just display packets that are above a certain size. So we say data length greater than, and then let's say 100 bytes, just to be on the safe side. And because we've only got the 2 packets, it's going to show both of those packets. But this is a great way to then use a command line tool to look at existing packet captures to see for suspicious or beaconing type traffic using that data length. And if you know that your DNS, most of your queries are a certain size in length, you can use this same sort of concept for the domain name query and say that's an abnormal domain name query. To actually look at the payload, we're going to use the -T command and say we want to look at a particular field. In this case, the field that we want to look at is the data field. So that's why we use the -E. And we get that in Wireshark, it would be down in that packet data pane that we would normally see. And we can see that it's in hex. That's not useful for us. So what we could do is copy that information and go to a tool on the web called CyberChef and do a hex decode recipe and see what that value is. Or we can try and use T-Shark and tell it to display the bytes of the packets. And so this is what it's done here. So here are each of the packets without the timestamp, and then we can see on the left-hand side, it's got the hex value, so which is up here, and then we've got information that is returned as ASCII or interpreted strings. And we can see here, blue chat, 10.100.17.48, transfer all of the funds to account number, and then there's account number. And you'll see that there's a response, a ping and a response, so it's going to repeat back that information. So malicious actors could potentially use this to exfiltrate data or messages out of your network. If you want to use a third-party tool, there is a tool called XXD that allows you to interpret. Don't know if I've got it installed, but let's try it. And it just grabs the ASCII value directly out. So looking at that information, it's definitely not a genuine packet. The packet size is too big for what would be a normal ICMP packet. And after further inspection into the data payload, we were able to see the ASCII value and the string that it said send information to this account. Is everyone able to follow along with that? If I'm going too fast, please let me know. Any questions? So the next packet capture is actually quite large. It's going to have lots of packets in there, and it's to do with suspicious file transfer protocol activity. Now, this is important. There's been an uptake of different types of attacks in the past month, and I'll talk about that in more detail once we finish this analysis, and we'll see how we go from there. So we've got two IP addresses that we want to investigate. So 10.121.70.151 and 10.234.125.254. And then we want to figure out what this error code means. Obviously, you could look up the error code on the internet if you want. And there's a bit of a tip down here, so you could probably guess what we're investigating at this point. So going back to our T-chart, I'm going to replay the FTP packet capture. And just to give you an idea of how many packets there are, I do a WCL and there's nearly 20,000 packets in this. So it's not something that you could manually go through and look at. So this is where being able to use some sort of scripting tool will make it a little bit easier. If we wanted to have a look at the first few lines, use the head command, and we can see there that, yeah, it's definitely got a, there's the two different IP addresses that we're looking at. And we've got port 21 going to 2217, 2227 is going to port 21. So based on that, we've got our three-way handshake, and then we've got a response 530, login incorrect. So we now know what that error code means. So the login is incorrect. Let's see if there's any unique IP addresses in this list. So let's look at the top talkers. So we're going to use the -T command, specify fields, -E, IP source, -E, IP.destination. We're going to do the sort, and we want to do a unique count. So we can definitely see the conversation between those two systems. And there's 11,266 packets going from the client to the server. So we can see that there's quite a lot of information there. If we wanted to, we could have a look at the conversation, so -QZ. Quite a lot of information there. We just want to get the overview and have a look here, and we can see the packets and frames and so on. What we can do is that there are fields that we could go using the -G fields command and have a look for FTP. And in particular, if we have a look at the head command here, we've got this response, 530 login incorrect. So we can actually use that field to then drill down on just those packets that are here. So if we go ftp.response.code equals 530, see we've got quite a lot there, and if I count, there's more than 700 packets with that response, login incorrect. So based on this, you could probably, depending on what the time frame is, you could guess that this is like a password spray attack, or brute force attack. And there's been an alert recently from Cisco about default credentials brute forcing and password spray attacks against various SSH FTP services. So just be aware of that. I might just share that link. Don't know if I've got it here. I'll share it a bit later on. Any questions about that? Again, using our fields, we can look for our IP source. Let's go have a look at this. So we want to drill down on the IP source. That is our server, the two. So dot 234 dot 125 dot 254, and we want to drill down on the request information. I do a dot rather than a dash. What we can see here in the request field is the details about the password that was used. So we've got pass, Merlin, Mercury, Mets, MGR, admin, and also the user details as well. So there's quite a lot of information there. If we want to see how long or the duration of this packet capture, there's 20,000. So what I could do to save time is I grab the first packet and then I grab the last packet, and then based on that, I should be able to see the duration of that. Or I can try and do it a simple version of it, and that is just doing the last 10 records. So T-shark-R, and the last 10 records, we can see here 44 seconds as the duration for the packet capture. There is an option if you want to see the first and the last packet using the head command and the tail command in conjunction with each other, but just using the tail command gives you the summary. Sometimes, instead of it being the duration, it might be the timestamp. So therefore, you would need to grab the first one and this last one to get your two timestamps and subtract from each other to get the duration. Looks like we've got a couple of questions. So he is asking about, may I know, is there a DDoS attack? In this case, it's not a DDoS attack. It was a password spray attack or credential brute forcing attack. And in regards to the fields, FTP requests, this is requesting the password. This one's requesting the username. So where it says user, that is what they're typing in. So they're using the same user admin for all of it, but they're using different passwords. So this is more a password spray or brute forcing attack. What we can do is, if we want to determine whether it is just the user, one user, or is it multiple users, we can use the grep command to say, go grab all the users from that. And we can see here that if we scroll back, there's quite a lot there. So what I could do is, oh no, the timestamps won't be there. I'm going to use and see how I've got multiple columns, 1, 2, 3, 4, 5, 6, and so on. I can use another tool called cut, and I can look for a particular delimiter that is unique. So see how there's double colon right here? I can use that double colon as my delimiter and say, cut this in half, this output, and I only want to get this second lot of information. So I'm just going to pass that to the cut command. I'm going to specify the delimiter as being the double colon, and then the field that I want is field number 2, and now I just get user administrator. So what I can do with that is the same as what I did previously, and that is a sort and then a unique count, and I can see based on that I've got 335 attempts for the user admin, 367 attempts for the user administrator. Can you start seeing the benefit of why the command line is a little bit easier? From my point of view, I like doing things in the command line because I can script it and drill down into a packet in more detail than just doing it inside Wireshark manually. Now that we've got that, we can do similar, but instead of doing it for our user, we can do it for password. And we can see that we've got quite a lot of different passwords. Instead of doing a unique count, it looks like it's just one attempt of each of those passwords. So I'll just do a unique, and then I can count how many different passwords there are in that list. So I get 703 passwords. And what I can do, if I just want the passwords, the same sort of concept as before, I can use the cut command, -D. The delimiter is going to be a space. And here I think it's field number 3. And there we have it. So I've now can save that out to a file and use that as a idea of an indicator of compromise and check other systems for strings with that attempt, or if there's ongoing attacks. Any questions about that? So I've now been able to answer this one here. So I've had a question in the Zoom about a rainbow table. No, a rainbow table, so normally a lot of modern authentication systems do not send the password across the wire. Instead, what they do is they will send a hash value across the wire that is used for a password. So rather than sending a clear text password, it just sends a hash value. And so for a brute force attempt, the system that I'm using to do the attack, I would need to calculate the hash value and then send that to the authentication system, so the victim system that I'm trying to attack. That is a lot of computational power I need to do over and over. And so a rainbow table is basically the hash value already been calculated and stored in a database. And so that means what you do is you send your brute force tool to go and grab that hash value and send it automatically. So you're using a rainbow table for that. And depending on the length of your password, those rainbow tables can be quite big. So terabytes in size. If you do a search on your friendly neighborhood search engine, so whichever you prefer as your search engine, DuckDuckGo or something, you can just do a search and see examples of that. So here's one, rainbow crack. And it's just showing you the how much computational power was needed to do it. And then you've got these ones here, plain length, 1 to 7 simple ASCII characters, 1 to 7 characters in size. It's 27 gigs in size. So it's a lot bigger than just doing, say, a straight brute force. I hope that answers your question. And I'll share this with you. Now we're going to use a protocol that you may not be familiar with. So we're going to have to use other skills to be able to interpret that. So currently, we're doing very similar for all our packet captures. We're doing a replay of the packet capture. We're then looking at the first few packets to get an idea of what the format is and what type of protocol is being used in the packet. And then we're going to extend it by using things like the fields options or display filters to be able to drill down on the data, and then passing that to Linux commands to search for particular packets or to extract certain information from those packets. So going back to the PDF, I'm sorry I'm not referencing the PDF. I'm assuming people are able to follow along. But down here, we've got, this is where we're at here. So on page 8 of the PDF. All the information that I've been talking about and doing in the lab is available in this PDF. So let's have a look at the chat. So what we've got is what kind of protocol is being used in this packet capture, and we can see that it's not using the file extension called PCAP. Instead, it's using DMP. So it's been captured using a different type of tool, most likely. It might be TCP dump, it might be dump cap, or other tool that is available. And then question 2 is, this is a conversation between 2 email addresses, but we don't know who they are at this point. And then what did they say about, let's say you're the systems admin, what did they say about you? So let's go have a look at the example here. So let's replay. Just powering up to try and get a shorter. So we can see here, chat dump. It's about 50 packets in size, and we've got this TCP MSN MS. MSN MS. So I could potentially pull out that field to get a better idea of what it is. So what we do have, so let's pull out that field, -T. We want to look at the protocols. So this is these protocol fields here. So we're going to say frame.protocols. We want to sort and do a unique count of each. And we should now see that we've got the ether type, IP, TCP, TCP, and then MSN, MS. So it's giving us information about the protocol that's in use. And so this MSN, MS is Microsoft News Messenger. So it's an old program that was used for messaging before Facebook Messenger and so on. We could use the conversation option. See what conversation we have. Oh, there's not much there. It's only between those 2 systems, and one of them's a private to public IP address. So it doesn't really tell us much there. What we can do is, if we're only interested in a particular protocol, we can say, just show us packets that are related to that protocol. And it uses a -Y. Don't ask me why it uses -Y, but it does. And I'm going to say the name of the protocol, in this case is MSN MS. And if I just pipe that to the head, I'm going to just get those packets. So we can see here that we've got 2 email addresses, Tesla_Brian and Tesla_Thomas as the email addresses. So we've got that question 2 and question 1 answered. But what we could do if we wanted to is we can say, okay, we've got these protocols, but we want to go and grab these text fields and just those fields there. So let's extend this out instead of -y, -ms, -t, fields, -e, text. And now we're just getting those text fields. There's a lot of information that's coming through. So what we're going to use is pass that to our Linux system, and we're going to look for details about who the user is. So I know if we scroll back up, I'm using that same sort of concept as before, but you can see up here on the second line, we've got typing user : and then the email address. Fourth line, typing user : and then the email address. So what we can do is we can say, okay, let's go grab just the string user : from these fields. And now it highlights it in red and just pulls back those fields that we want. We can see here that we've got the username directly afterwards. So just like what we did in the previous example, we can do another passing and cut it at that semicolon. So we can use the cut command. The delimiter that we want to use is the semicolon, and the field that we want to grab is field number 2. Actually, field number 1. Let's see what we get. We now get the email address there. The other option is, see how we've got this comma? We might be able to get more detail by using that instead of the actual colon. So let's drop that to a comma, and we're going to specify, let's say, what's in field number 4? What's in field number 5? There we go. So we've now got, let's drop this. So we've got, and so this is all I'm doing is experimenting with the different fields until I get what I'm after. In the PDF, there is a working example of, after a few experiments, I've used this T-sharp command to do this here. So I've said, grab the text field, search for the user : cut it on the comma and grab fields 4 and 5, and then cut it on the semicolon, and then cut it on the double slash, the single slash, and then do a unique sort. It's a long-winded command, but essentially it should bring back just those field names for the emails. And there we have it, those 2 email addresses. In regards to what did they say, we can use the search for the shell. And this is where they will be typing in information about that. So I want to look for the keywords shell. And what we can see here is we've got shell, hey Brian, as a string. Then if we scroll down, we've got another shell, and it responds with, hey man, what's up? So If we wanted to, we can drill down specifically on those using the cut command. And it now brings out just those messages. And so in this case here, they're saying the new IT guy is a real jerk and they should hack the server to mess with him. So it shows you that depending on the messaging tool that you've got and whether you're using it on an enterprise system or not, it may be in clear text without you knowing. So you need to be careful on how you use enterprise systems. MSN Messenger was clear text, had no end-to-end encryption. Modern day protocols do have end-to-end encryption unless you've set up some sort of transparent proxy to be able to intercept the messages, but it's getting more and more difficult to eavesdrop in on certain conversations on commercial tools now. Any questions about that? Can I get a show of hands of how many people actually have Wireshark installed? Zahir, excellent. Because we're probably going to run out of time. So I want to introduce you to the concept of using Wireshark for some of this. Now, I haven't gone through the T-Shark packet capture. I will leave the virtual system up for the rest of today as well as tomorrow if you're interested in doing more of the T-Shark to do capturing of packets. But I should expose you to the Wireshark component. So everything that we've done in T-Shark, we can do in Wireshark. So I'm just going to show you the examples for on my open folder where I've got it. I've already downloaded and extracted the exercises PCAPs, and I'm just going to open these up. So I don't have, here's the Telnet. So in regards to Telnet, I'm going to open it up with Wireshark. And what I will do, which I should have shown you this originally, if you go back to the events page, you scroll down, I have the Wireshark PDF there as well. So I'll just open that up. Maybe I won't. If someone can share this link to the audience, that would be appreciated. I'm just sharing a GitHub page where I've started to convert some of the lab guides across into lab instructions. So Zahir, you are able to use this the lab guide after the session, but you would need to have access to a Linux system. So I haven't quite put it into the Academy just yet. So that's why I'm getting you to SSH into our jump host and into the system. So once I've got it on the Academy, I'll share a link into that same event page, which will go into past events. In regards to some of the other exercises, if you go to the Academy page again, there's this APNIC Academy that is giving you access to a virtual lab that goes into details about packet analysis and signature analysis. So it shows you how to do TCP dump commands on some of the packet captures that are inside this file. And then I think it also has Wireshark installed, and it goes into a lot more detail as well. So if you want to continue with your packet analysis learning journey, have a look at this lab. And then there's a couple of other labs here where I do some other types of packet analysis using Zeek. So this practical packet analysis here. So it goes into a lot more detail as well. Whereas this is more the introduction to packet analysis to get you started. And we could spend, like from my point of view, I could spend a day just showing you T-Shark, and then another day just showing you Wireshark, and another day showing you TCP dump. And then, yeah, there's a lot of information. So looking at the PDF, which is broken, I'll fix that link later on, but hopefully everyone's got access to the markdown file that I just shared, and I'll show you that here. And it gets you to install it on a Linux system if you're interested in that, checking it out. But the idea is that you're going to download these packet capture files, open up Telnet, and then it goes into details about how many packets there are and whether there's a display filter in place at the time. So in my case for Wireshark, I've got the displays of 92 packets. I've got a total of 92 packets, and my profile has been set to default. What I can do is I can create a custom profile for when I do different analysis. So if I go to my edit, configuration profiles, and I can go and create a new profile. And today's Saturday, so I'll just call it Saturday. Click on OK, and you'll see down here my profile has changed to Saturday. But you'll see what it's done in my window is it's dropped out the diagram view, the packet diagram view in the bottom right-hand side. So what I can do with that is I can go and change my view preferences for a format that I like. So if I go up to Edit, go down to Preferences, I can see my layout options here. So this is the top-down approach. The top takes most of the top panel, and then you split it in the bottom half, or vice versa. You have the top half split, the bottom half taking the whole width, and then you've got various other ways of doing it. And then in my pane one, it's got the packet list, which is what we can see in the background here. Then I've got my packet details on the left-hand side, and I'm going to change the right-hand side to my packet diagram. I click on OK, and that's affecting my Saturday profile. So what I can do is I can say, let's look at the destination address. So 192.168.0.1. So I'm going to right mouse click on that, and I'm going to say apply as filter selected. And you'll notice up in the display filter area, it's actually typed in ip.dst equals 192.168.0.1 for me. If I want to add telnet, I can right mouse click on that, and I can choose and selected. And that now adds that in as well, which is a little bit more complicated than what I was expecting. See how it's got this ws.col.protocol telnet. What I can do is I can clear this filter and I can make it a little bit more simple. So sometimes using the automation tools makes it more complex than what it needs to be. So I'm going to do the same process as before. I right mouse click, apply as filter, selected, and then I'm just going to type and telnet. And that does exactly what the previous display filter did, but it's a little bit nicer. And it's similar to what we were doing in the past. And see how we've got this telnet data, but it doesn't really tell us information. I could potentially go and change my profile back to, can't remember what my Friday was. No, I won't do Friday. That's too large. So I'll go back to Saturday. I could change this to the bytes and drill down on it. But what I can do is I can follow the TCP stream. So I can just right mouse click on this and go follow TCP stream. And we can see the details there. What I can also do is, instead of getting all the information from the server, I can just drop it out so I only get the client information. So the information that is being sent to the server. So it filters out all that other stuff. If I clear the display filter, and up here, let's try one of the contains. I can say, look at the telnet protocol and see if it contains the string password. And this version of Wireshark looks like it no longer supports the contains option. I'll need to look at that and fix that later on. Going back to the display filter that was there previously, from the drop-down box, I can see that I've got the past history of display filters. So I can just click on that to reapply again and press enter. And I've got this telnet data column. So what I can do is, using my same profile for Saturday, I can go up to edit, go down to preferences, go to columns, and now I can add in extra columns if I want. So I'm going to add a column, and I'm going to drag that up to where I want it to be. So after length, and I'm going to change this to custom. So type custom. And then in the field, if I get in the right location, the field I want, which is telnet data. click on OK, and I now have, and I didn't rename it, but I can see here I've got telnet data, and I can pull out just that information that way. And what I can do is if I just only want it from the source, and I can now just grab the telnet data and display it that way. How's everyone going with that? So that's using Wireshark. So in this case here, we've set up our own custom profile. We modified our preferences to change the Wireshark display windows. We then used some display filters, and we used Wireshark's apply to filter option. And then we added a custom column to our packet view to be able to see the extra data from there. So covered quite a lot with that one packet capture. Some of you may or may not have used that in the past, but that's there. Zaire, I hope I answered your question in regards to how to view the telnet password.
Thank you. I think he's asking how to view the telnet password, which is used, but I think it was displayed just before, yeah.
The telnet password is here in this field here, so using that new column.
Thank you very much, Warren. And I think this is our Q&A session now. If there are any questions, the floor is open, and you can ask your questions, type them in the chat box or the Q&A session section of the Zoom. Okay, meanwhile, you can update us if there is any AI and machine intelligence contribution to the automation and efficiency of packet analysis. Is there anything so far, Warren?
Yes, there is. So there's getting more and more tools that are starting to help you with that. So, for example, you can have you heard of ChatGPT? So if you've used ChatGPT, you could use that to create your display filters, and you can say, I'm using T-Shark, I've got a packet capture, and if you get the first bit of information, so you know how I use the head command, and you paste that in to the ChatGPT window, or you convert it to a PDF and upload it, and you can say, this is what the output is like using this command, how would I do this, and so on. But there are tools out there that I haven't investigated enough at this point, because APNIC doesn't want to use AI as such, but there's pen test tools. I can't think about research paper, but you can use machine learning to do packet analysis help as well.
Perfect.
Can't remember which language.
So, yep. Is there any questions? I think no. So thank you. I think it's time for the question that I ask our esteemed presenters at the end of the webinars. Is there any book or reference you would recommend to our participants?
Yeah, I've got a T-Shark book. I don't know if I've got it here. I'm not on videos, but I can, in the events page, I will put some books there for you to read. But there's a great Wireshark introduction to Wireshark on their website. It's a free ebook that you can use, and then there's a couple of T-Shark ones as well. So here you've got the Wireshark Users Guide. It's a great resource as a starting point.
Exactly.
It's 370 pages, and it breaks it down into quite a lot of good examples, how to use it. Lots of resources there. In regards to other books for packet analysis, I like T-Shark book, but I'll need to think about it. I've got too many books in my head at the moment.
Okay.
But yeah, definitely the free ebook on Wireshark.
Okay.
I think there was a book. I can't remember the publisher. No Starch Press. That's the one. Practical Packet Analysis.
Mm-hmm.
And then that's expensive, that one, that training, but I definitely recommend Chris Sanders' information.
Okay. Sure. Thank you very much. Thank you for your insightful presentation and the lab practice. And thank you everyone for being with us till the end of the presentation. As last remark for today's webinar, I just wanted to remind you that be careful while using the packet analysis, because sometimes intercepting and analyzing network traffic without proper authorization or consent may violate laws related to privacy, data protection, or computer security. So make sure you have consents and you're authorized. Thank you, everyone. I hope you enjoyed the webinar. Stay tuned with us, and for the next month's webinar, we'll post in our social media pages. Have a nice time until then. See you. Thank you, Warren, again.
Thank you.
See you all. Bye.
Bye.